We've spent a lot of time on trigonometry, and I'd like to thank you for your patience. I also want to assure you that it is worth the investment of labor to study these things, as they are quite interesting. We've spent a lot of time deriving trig identities, exploring their uses, constructing a table of exact values from geometry, and reading values off that table, including ones that are between the lines, so to speak. So you might be asking yourself, why do I need to know trigonometry? What is the practical use? Well, historically speaking, trigonometry was developed largely in part to study astronomy and also applications in surveying. Let's take an example of surveying. Say, for example, there's a tall building in your neighborhood and you want to know what the height is. Well, how would you go about doing that? I'll draw a little stick figure here at 5 feet tall. Okay, and let's say to eye level, you measure from the distance of the building to the point you are standing, and that is 50 feet. You are standing 50 feet away from the building. Now, from that point, you look to the top edge of this building. I'll draw a line here to represent that. And using a protractor, you measure that to be 35 degrees. That is your angle. All right. Notice this is a right triangle. We're assuming the building is perpendicular to the ground. From this, we have enough information to solve for the height, I'll call h, of this building. How are we going to do that? Let's set up a ratio. We have an adjacent side length here, and we're looking for the opposite. If we remember from our early definitions, opposite over adjacent is tangent. So we have tangent of 35 degrees. That's my angle theta. Now, tangent is opposite over adjacent. The opposite side is this h. Don't forget to subtract 5 because we're looking at it 5 feet above the ground. Adjacent is 50 feet. Okay, so we have this ratio set up. Now, we'll pull out a calculator. Make sure your calculator is set to degrees and not radians or some other measure. I'll punch in 35 and hit the tangent button. I get 0.7002 is equal to h minus 5 divided by 50. Now it's simply a matter of algebra. Multiply both sides by 50. So 50 will cancel. I get 35.01 is equal to h minus 5. So now, to get h alone, I add 5 to both sides. 5 will cancel, and I get h is equal to 40.01 feet. Don't forget my units are in feet. So there you go. If you're unable to run a measuring device from the top of the building to the ground, you can measure along the ground and find that angle. Then we can use trigonometry to indirectly determine the height of this building. There is just one application of trigonometry. Can you think of other ways that we can use this? Post your thoughts in the comments below. I'd love to hear what you have to say. As always, thank you for watching. I will see you next time.